Now I find the Q point. Three-step process. What are the three steps? Find IB, find IC, find VCE. So let's find IB first. IB. IB is this current here. And that current is, imagine that current to be the current in that resistor, which is the voltage at the top minus the voltage at the bottom divided by the resistance, V over R. So the voltage at the top happens to be, is there a VBB here? No. What is this voltage here? Is it VCC? Minus voltage at the bottom. What is the voltage here? To ground. It is the voltage from the base to the emitter, which is 0.7. So VBE divided by RB. Everybody see that? Because I merged VBB into VCC, wherever I had a VBB in my calculation earlier, I used VCC. So VCC is 15, VBE is 0.7 divided by 500. How much? 28? Point 6 microamps? 28.6 microamps. It takes only a little bit of base current to turn the transistor on. IC is now going to start flowing, and IC is going to be beta times bigger, HFE times bigger, and HFE is 150. So it's HFE times IB. 150 times 28.6 microns. What do you get? 4.29 milliamps. Put a cube beside it. So that's one of my cue points. VCE is the other cue point. So VCE is the voltage from the collector to the emitter, and I use this IC value to find the voltage here. The total voltage minus the voltage drop at RC is the voltage at collector to emitter. So it's VCC minus IC times RC. This is the voltage across the resistor. So that's 15 minus IC is 4.29. RC is how much? 1.5K. What do you get? 8.5. 8.5? 8.56. Write down Q beside it. What does the Q mean? That's the Q point. That's the operating point of this transistor in this circuit. So the operating point is somewhere on that load line. So let's put the 8.56 volts on the graph now. 0 to 15, halfway is 7.2. 7.5. So where's 8.56? Just on the other side. 8.56. Go up. Hit the load line. Go across. Indicate your IC value. 4.29. Q. If you want to write down the Q value as an X coordinate and a Y coordinate, what would you write it as? 8.56 volts, comma, 4.29 milliamps. So that's our example. In the lab, next week, what we're going to do is the next page, page 7. Have a look at page 7. What does page 7 show? Midpoint biasing of the circuit. What does midpoint biasing mean? Where would be the midpoint on this circuit as far as the Q is concerned? What would be the VCE value if it was right at the middle? Q, midpoint would be how much? 7.5 volts, wouldn't it?
Yeah.
And what would be the current? 5. So this is Q midpoint is halfway on that graph, 7.5 volts and 5 milliamps. Okay? Half of VCC on the x-axis, half of IC sat on the y-axis. Okay? So that's what we're going to do next week on Monday. For now, we put this away and we write a quick and easy and painless with